This is the Web Platform Podcast, episode number 102, Offline with GunDB. I am your host this week, Danny Blue, and with me as always is Justin Ribeiro.
Hello, wonderful people.
And Leon Revel.
Hey, everyone.
And we always have special guests, right? Never a non-special guest, but
they're all very special.
Very special. But our special guest this week is Mark Nadal.
Hey, everyone. Thanks for having me on the show.
Yeah, absolutely. Thank you very, very much for coming on. Mark is the creator of GunDB, which is what we're going to be talking about today. So, real quick, Mark, can you just give us a quick background? You know, who you are, what you do, what you like.
Yep. I hail from San Diego, and I would say I am mostly a logician or mathematician, or even philosopher if you want to get that crazy. But I realized a path through academia is not the choice for me, so I dropped out and realized, well, I probably don't have much of an opportunity being a rogue mathematician. So I quickly found what is the closest cousin to logic that I could support myself with, and programming, of course. But that kind of bit me in the butt, because the next 5 or 6 or 7 years was just learning how to fight with a computer with syntax bugs and front-end stuff and learning the back-end, and it was a nightmare. But I have come through those terrible, terrible times, and now I get to fight with really annoying distributed systems and figure out why do computers not work with each other. So that's kind of a quick summary of my background.
So did you go from a positive sort of philosophy background into sort of a nihilism? Like, did nihilism take over as year 7, you're like, I don't understand. Why does the debugger hate me at this point?
I could see easily falling into that trap, but no, I've managed to try and have a pretty optimistic outlook on life ever since. But yes, when I look at computer systems and see how deterministic they are, I wonder if the universe has chosen a fate of syntax errors and compiler problems for you. But no, we're overcoming those things. We have JavaScript, which has the JIT compiler, and then I find out that Chrome has some of the worst performance possible, that they don't do inline caching, and I have to rewrite all of my source code to manage why on earth it can't handle iffy functions and anonymous functions. But that's a separate discussion, and that was the...
I feel like that's an entirely different podcast. The philosophies of the greats combined with programming. There you go. If you're a listener out there, free podcast idea. You heard it here first.
You can have that one. Although I do like the idea of a rogue mathematician. I feel like that's one step away from supervillain.
Good point. Well, I'm going to have a defense here, which is a man I really, really like and respect is Ryan Dahl, who invented Node.js, and he was an applied mathematician or a theoretical mathematician, I forget which, and he ran away from math. I think it was his PhD thesis, and was wondering why Ruby was so unearthly slow, and found out, oh, it's because it does a separate process for every request or something like that. And so we have this mathematician, right, that probably doesn't have as much of a clue about programming as he should, getting into these things and realizing, oh, what if I just took a language that was designed for concurrency and asynchronous behavior and use that for an upload stream? And then he was like, oh, shoot, JavaScript is that way. Oh, this is going to be terrible. And then he wrote Node.js. And now here we are talking about JavaScript and Node.js and even databases in JavaScript. How freaky is that?
It is pretty weird when you think about where that came from. It's just bizarre.
Are you guys Node.js fans? I hope so.
Never used it. I've never touched it. It's sort of outside my realm. I hear it's a thing you write stuff for, and then it just happens.
Yeah, it's pretty magical.
Is it magical? All programming is magical.
It is all magic.
It's all just magic.
You have to be a wizard to use it, though.
Yeah. Any significantly advanced technology is indistinguishable from magic? Isn't that?
That's why I wear a wizard hat at work.
Okay, all right. We're going all over the place. Let's start getting close. So brought up Node, where that came from, and brought up databases, and that brings us around to the thing that we want to talk about with you this afternoon, which is GunDB. So, real quickly, give us the overview of what GunDB is and how it got its name.
For most people out there, they're probably familiar with Firebase. You can think of Gun as pretty much just an open source Firebase. Now there's lots of other cool things going on here, like it has graph features, so you can have relational documents and junk like that. It's also offline first, but I think Firebase introduced that like a year or so ago. And the biggest kicker that we'll probably spend a lot of time talking about is distributed systems or decentralized systems. Gun is completely decentralized, which means if your server crashes in the middle of the night, you don't have to worry, because unlike MongoDB and MySQL and Postgres, most of the mainstream databases out there, it doesn't have a master-slave architecture. And this is honestly one of the biggest reasons why I got into building Gun. Well, I guess that's a separate question. You're asking me why did I call it Gun in the first place. There's a couple pieces to this. First off, I find that the database industry as a whole is somewhat, this is me saying I didn't want to go into academia, but I was a mathematician and logician. I find the vocabulary they use to be kind of snobby and elitist. That's why I really like Kyle Kingsbury's work. He comes in and just trashes all these databases out there and brings that discussion into the lay programmer dialogue by using funny things like, Call Me Maybe Jepsen series, where he mixes popular culture with stuff. It opens up the discussion about these black box magic machines. If you think programming is black box magic machines, managing state, which is what a database does, is even more of a magic. So I'm losing my train of thought. Gun, right. So I find the industry is otherwise being elitist and snobby. I think things are starting to open up, and I kind of want to represent this idea of causing a revolution. Now, I'm not calling anybody to be violent in any way, shape, or form. I don't want that. But data is now the bullets of the real world. So NSA, Snowden, all these kind of disastrous stories going around about government spying on us. People's information is valuable. It represents their identity. And when you know about people's identities, you can easily persecute them. You can easily judge them. You can easily... It's just dangerous to not have an understanding of privacy. And I'm opening up so many threads like a Pandora's box. So Gun is this idea of there is danger when we have all this access to data, and we need to be responsible with how we use it. But the other side, which is the more tame side, other than this revolution and this movement, is that Gun is an acronym. I hate acronyms, so don't tell anybody this. I know we're on a podcast. So Gun stands for Graph Universe Node, and we can kind of get into the graph side and some of those things later. But it's an acronym, but also a movement and an ideology.
So you compared GunDB briefly to kind of Firebase. So is it kind of cloud-based? Is it like an online portal where somebody signs up and creates different databases, or is it a completely open source and you can create your own servers and scale them in that way? Kind of how does that work?
Completely open source, and you can run it on your own infrastructure and scale them up. In the future, I'm sure, because we're an open source company, we'll have to figure out other monetization strategies. We'll probably have a database as a service that competes with Firebase, but our goal is to empower everybody out there first with being able to run their own, basically run their own database as a service first. So it's open. You run your own infrastructure. You don't have to use us or pay us.
Cool.
Yeah. Very, very cool. It's nice to see things like Firebase are extremely popular, largely for their real time, and largely because they are very easy. It's very easy to use. So I like when I see things like a GunDB that are out there trying to give you those same things, because a lot of times you'll be working in an industry, government, for example, where storing your data in somebody else's cloud is frowned upon. So having something like this that you can install and use on your own is really, really, really good. So can we get into a little bit? So we talked about the kind of history of the name and stuff. Can we go into exactly why you built it? Like, what the specific problems were that you were trying to solve, and could you not were you trying to solve a problem and you just couldn't find an existing solution that worked for you?
Yeah, so I was accidentally getting distracted into that rabbit hole. The history is that I was running a master-slave database, and I just kept on having problem after problem. My previous project was a collaborative web design tool, which I'm still going to pick up in the future because it's kind of my baby and my passion. And we had this one night where, like, I think 300 people signed up because we had some evangelism going on, and everything just crashed and blew up. And it was the middle of the night, and I wake up because I get the alert that everything's down, and I log into my server, and I find out that the entire hard disk is filled out because I had designed the system to isolate users' data into kind of separate database instances. But what that had done is it had pre-allocated 2 gigs for every single user, and then I only had like a default 8 gig hard drive on an Amazon instance. This is back when I was very, very naive about DevOps and backend stuff. I thought if I used Amazon, things would auto-scale for me. I didn't know I had to program all of that magic myself. So I've just had so many problems where the database has kind of fundamentally been the bottleneck of what I'm trying to do. I'm not interested in databases. I do not like databases. I want the database to just run, to just work, so I can do my front-end application. But it doesn't matter whether my Node.js server is still running. It doesn't matter whether the CDN is still delivering code and assets. It doesn't matter if my front-end code is working flawlessly. If the database is down, you're screwed. The entire system fails and topples on top of each other because your app winds up fundamentally being your user's data. And that is the lifeblood of your system. And if the heart isn't pumping, you're dead. So having that problem with master-slave systems made me say, well, why isn't there a database out there that can survive failure? Like this seems like a more obvious thing. And sure, you can run these clusters with MongoDB, but maybe it's because I'm coming from more of a philosophy background and I don't know much about the back end, but I shouldn't have to be a superhuman programmer like Justin out there in order to know how to run these clusters of databases. And a lot of the license for databases out there, even the open source ones, require you to purchase a license to have the cluster capabilities. Not all of them. So I was like, I want a database that the front-end developer can run and is still going to be fault tolerant. So what does that mean? Well, I have to be able to use technologies that front-end developers know and understand. That's JavaScript, but JavaScript is like the worst programming language to implement a database in. So that's kind of the background. I just fundamentally trusted these database authorities, and probably because of my own naivety, they failed on me. And I said, no more. I'm going to try and do it myself. So.
Wow.
Now, to get in specifically, were there other solutions out there that did this? Yeah, we do see Cassandra and React as being master databases. But in order to start with them, you have to have in order for them to be fault tolerant in the first place, you have to have at least like a 3-node cluster to begin with, because having multiple machines, multiple database servers is what gives you that fault tolerance. If you switch things around, though, and start implementing your database in JavaScript, you have this very interesting effect where the browser can actually be the fault-tolerant aspect, which winds up meaning every single connected user to your service can provide redundancy for you. If you hit our repo, one of the 2 demo videos we have on the home page, they're just a minute each, so they're very, very, very short, shows how I can completely destroy every single server that's running, delete the data or corrupt the data, but then when you spin up a new server and the users reconnect, everything syncs back up because the database is running in the browser, and it's doing replication from the browser.
So kind of, I don't know whether many people are familiar with CouchDB, but obviously that's something that kind of runs in the browser and kind of achieves this synchronization from browser to browser or browser to server with CouchDB. Is it kind of similar to that? Does it work in a similar way, or is there something fundamentally different in how it works?
Well, it is the same in the sense that it synchronizes and is offline. The algorithms to which it uses for conflict resolution and concurrency are different. But yes, it's like Pouch in that sense. And we really got to commend the Couch team and the Pouch team that I feel like they really pioneered the offline first stuff way before a lot of the other people. But unfortunately, I feel like they didn't win the NoSQL war. That was Mongo. And they kind of, I mean, people use them, they know about them, but they didn't have the same type of hype behind them. And so thus, the thing that they were pioneering, offline first, has now taken quite a long time to now get around to us other developers, where we're now starting to see the importance of having offline first apps, especially with the advent of mobile behavior all the time. So, yes.
Could you describe in a little bit of detail of why is offline first so important? Why is it important to web apps?
Absolutely, because at the end of the day, machines are fundamentally offline, right? The idea of networking or communicating, or the idea of the internet or web, right? If we go back to the early days of the web, Tim Berners-Lee and stuff, web is decentralized. There is no master. So that means it is independent machines, typically universities, that are communicating with each other. And when you have a network, if you have internet, as everybody knows, even people in San Francisco or me that has Google Fiber, that's free internet they just give me, it goes out, it hiccups, it fails, it blows up. So if by definition you have internet or some communication or network, at some point it will fail. And you do not want your user's experience to also fail if the network happens to go out. The network is something you cannot control because it is pipes going through the ground. It is pipes that are getting broadcast over the air from the pipe into the air broadcast. So that is hardware you cannot control. And you do not want your product, your experience, to be at the whim of the disasters of those things, the failures of those things. So offline is very important to give a good experience to your end user.
So I totally agree. And offline is something that's becoming, I think, more and more kind of in the developer zeitgeist at the moment, with the idea of progressive web apps, or however you want to describe them, where one of their things is like this ability to run offline. One of the core technologies that people are using for that is something that is coming to all the browsers, which anybody's listened to this show has heard us talk about service workers before. Do things like service worker in the browser mean that you don't need something like GunDB, or is it something that, or is it the type of thing where you can use both together to achieve your offline first idea? I know there are a few things. Again, service workers are all like they run on the front end, but if you just wanted something for offline, do you use GunDB or service workers, or can you potentially use both?
It's a great question. So doing offline first, to me, the harder problem is what happens when you reconnect and how you synchronize the information. Service workers gives you the ability to handle, technically, programmatically, things while you're offline if you want to catch those things. So service workers are a tool that allow you to do things while offline, but they're not concurrency algorithms. They're not concurrency control mechanisms. They don't give you the ideas to reason about what happens while I'm saving data or doing things offline. They just let you do things offline. So I'd argue Gun is much more about the conflict resolution algorithm, the concepts, the ideas. Sure, we bundle it up into a nice interface for you, but it is more about the idea and the algorithms behind that and handling those situations than necessarily just giving you a tool. So to be honest, Gun doesn't out of the box give you the tools to just run while you're offline. You still have to, let's say, decide that you want to have an app, right, that people have installed on their phone that will still load if the network is completely down, right? We don't automatically do app cache manifests, which Service Workers is now kind of replacing. I mean, Service Workers is much more general. So we're not automatically kind of giving you the tools to just magically have your site running while you're offline. That's still up to you to figure out and to make those decisions yourself. But we give you the tool for then how do you synchronize the information, and then when things comes back online. Now, hopefully in the future we will add more plugins and features that give more tooling to that, but that's not the core of Gun.
No, very cool. Thank you.
So, yeah, I mean, in terms of offline, I mean, offline is a big sort of topic, particularly when you think about the way data works, how background sync works. I mean, background sync is really just starting to land, which is based on the service worker sort of side of life. But when you start to talk about resolution of data, I mean, how are you doing sort of your concurrency? Like, how does the concurrency operate in a manner that is something that is sort of sane? Like, you know, you talk about Couch or Pouch or a lot of other things. You talk about MCC or multi-currency control, you know, and sort of the notion of how you int transactional memory and everything that goes into that. I mean, how does GunDB sort of handle that situation where, you know, what makes it sort of, so, you know, pun intended, bulletproof?
Yeah, so this is an entire topic.
I didn't say it was a good pun.
Hey, I think puns are good. It keeps people laughing, which is better than being boring. So this is a great question. It could be an entirely own talk. I've done entire talks that are like an hour long just on this. I'll try and sum it up though, so I'm not going to go into too much detail. If you want, we could explore that more, but
we can always add links to the show notes, but
yeah,
just a general overview, I think, because I realize not a lot of people, if you're, you know, I've probably worked with, I mean, a lot of people, again, MCC might be something you've heard of, but not necessarily something that most people implement,
right?
Because it sort of comes inherent with a lot of the transactional systems that we use when we talk about databases and whatnot.
So if we just assume that if we save data and it's just going to work, so let's say while somebody is going through the metro and they're on their phone and they write a tweet or they save data to whatever your unicorn startup is, and they're disconnected, and let's just say we go ahead and save that to local storage or something like that, such that when we come back online, we can resolve it. What winds up happening is if two people have written to the same record while offline, when we come back online, oftentimes people just assume that whatever new incoming request of data is the most recent one. So the person who edited the content, let's say 20 minutes ago on the subway, when they come back online now, okay, the other person who had edited, let's say, the title to this show that we're all able to access, let's say Justin edited it 5 minutes ago, when the other person comes back online after the 20 minutes, even though his edit from a time perspective is 20 minutes in the past, when Justin's machine receives that update, it looks like it's, quote, newer because that's when the machine's now processing that data. So it might overwrite Justin's data. There's no indication of which one is more correct. So people then are like, aha, why don't we just use timestamps? Well, timestamps are really dangerous because if I edit my machine's clock to say I'm 2 years in the future, and I mean, how many times did you guys do this with the 30-day trial, you know, software, where you would set your machine clock to be like 5 years in the past, so that way, you know, you could always use that 30-day software because the 30-day software was using timestamps to determine whether. So timestamps are really dangerous. If somebody sets their clock to 2 years in the future, then their edit is going to win for the next 2 years. That's dangerous. So then you start getting to things like vector clocks. Leslie Lampour has lots of writings on this. This is back in the 70s. But the problem with vector clocks is that you kind of have to have every machine known in advance, because each machine has their own clock. There's different types of vector clocks implementations, but these are some of the first. And this is back when you didn't have a cloud where you could just spin up millions of machines, right? You typically had these university machines that were dedicated. They're not going to go away. They're always going to be online and maintained and provisioned. So you could say, oh, we know that there's Alice, Bob, and Carl, and we can now use a vector clock that both Alice, Bob, and Carl all have their own vector clocks, and we can exchange the vectors as well as the data that we're saving. We can use those vectors to resolve. But those don't work really as well in transient systems, and when there's failure, there's all sorts of edge cases. Anyways, the reason why I mentioned vector clocks and timestamps is because at the end of the day, we can summarize Gun's conflict resolution algorithm as being a hybrid CRDT of lexical comparison, vector clocks, and timestamps together. If you think of it in this way, the vector clock side can protect you against the timestamp exploits, but the timestamp side can protect you against the transients or the ephemeral machines that are coming on and offline constantly. And then the lexical sort winds up just giving a deterministic element that if there winds up being a conflict on both the vector as well as the timestamp, we can resort to a very naive lexical comparison and choose whichever one has a higher lexical value. That sounds kind of dumb because you're saying, why do I want my business logic to resolve to whatever data has, a higher lexical value? You're not supposed to run your business logic off of the Gun's core sync algorithm. You're supposed to use Gun's core sync algorithm to just sync data, and then you choose at the application layer realistically how you want to sync, not sync the data, how you want that data to control. So Gun is not a silver bullet for business logic. You're still going to need to implement things like directed acyclical graphs to handle causality of data. You're still going to need to have things like blockchain algorithms if you're dealing with like accounting or any type of mathematics stuff, or some sort of commutative data type like a CRDT, which is its own fancy discussions. Or you're going to need to use NTP, Network Time Protocol, to synchronize the clocks of the machines if you're doing like gaming, to make sure that these machines all are at the same state of time. So Gun at its core is to say, here are sensible defaults that will get your data to sync that you don't have to worry about, that's going to work. But if you do have any higher level complicated business needs, you're going to have to use that algorithm in specific ways and add things on top. So I'm seeking a more primitive algorithm that you can build anything else on top that allows for emergence. Did that answer your question, or was that way too philosophical?
No, it was just all out there. It was just gone. You lost me halfway through. No, I'm just kidding. No, this idea of building things on top of it, because having sort of read the documentation and kind of peered through it, it has a very open approach to read writes, where you're sort of resolving this, and the resolve looks nice and it all kind of works, but you do have to sort of build on top of it to get the sort of additional things you're going to want out of it. So for the things like authentication, or things like limiting read writes based on keys or things like that.
Correct.
That would be a safe assumption, right? Based on the way it works now.
And the reason why we've gone down this route is, I've been inspired by the Unix philosophy, and I'd also argue the Node.js philosophy that goes with the Unix philosophy. Node.js says most things should be implemented in userland, and then you get NPM and now people fighting over left pad algorithms. So there can be an extreme there. But I think software should fundamentally do one thing and one thing well, and then you can take those pieces and put them together to build higher level things. As soon as you get software or a database that is a solution for anything and everything, that starts to be where you get a black box of magic, because you as the developer cannot reason about the logic and the flow of the system, because at some point it goes into the database and now you don't know what's going on, and at some point it comes out of the database. It's nice to work with those systems, it can be, but at the end of the day, when your application starts to grow and you're scaling up, you need to be able to debug what's going on, and you need to be able to reason through every single piece, and that means understanding the full stack. And when you have things like the Unix philosophy, piping philosophy, streaming philosophy, the Node.js philosophy, you say, I have this piece, it does the one thing that I know it needs to do, now let's compose it together, and now I understand the system as a whole. So yes, we're not going to be the black box solution of everything. Hopefully we'll add plugins and features on top that solve specific needs, so you don't have to worry about being, the academic or the mathematician. But at its core, Gun is trying to be as simple as possible, solve one thing, and do it well.
So that actually brought up a question I had about that, and it's kind of about that philosophy in general, and we have a good example of it with GunDB right now. And my question is does that philosophy ever hurt adoption at all? Because you were talking earlier about wanting to give front-end developers is something that's just going to work. They don't have to worry about architecting a back-end solution and things like that. One thing that almost everybody's going to need is some sort of an authentication mechanism. Like this, so this is just the example, right? So do things like this where it's like, okay, I have GunDB, now I have to go figure out how I do this other part. Do you see that hurting adoption at all? Or like you said, is that something where the plugin system comes in to help out, where it's like, okay, here's GunDB, and here's the GunDB auth plugin that you can use on and on and on?
Three things. Just immediately, I'm going to say you have Express, and then you have Passport, I believe. I haven't actually used Passport. So I'm going to say, no, there isn't a problem with emergence and composability in plugin structures. However, second point, I do think, yes, it's possible that it does hurt adoption, because we're getting into this monolith framework era where it's like, oh, here's Angular, and you don't need to know how to code. You just write some Angular stuff. And I'm trying to think of some other monolithic, sorry to make kind of Angular specifically. Frameworks I've found are generally a bad direction to go, because third, no, front-end developers, even newbies, okay, we have this idea that we need to just give them this framework to get them copying and pasting and going, but that is not what we want. We've spent the last, I'd say, 2, 3, 4 decades, Justin probably knows this better than me, trying to create all these abstract, sorry, Justin, all these abstraction layers.
Wow.
All these abstraction layers over networking protocols, up to the point where, and TCP is nice, HTTP is nice, UDP is nice, but it abstracts to the point where, as programmers, when we want to do something, and Node.js is a good example here, we have to actually reverse all that to get back to just the pipe itself, the Unix stream. And sure, there's still something like TCP or UDP or frames going on. I don't actually know enough about that to speak on that. So my argument is that even newcomers, okay, understanding programming is just 3 concepts in general. It is data, it is communication, and it is manipulation. We need really good tools that allow us to do those 3 things. Okay? We don't need these abstraction layers that handle all of the magical AJAX for you, plus authentication built in, because as soon as you want to do anything that the framework does not already have an assumption to do, the newcomers is out of luck. They have to rewind. They have to figure out how they're just trying to get these 2 pieces to fit together, whether that be, let's say, React and X, or Angular and Y. How do those pieces fit together? It can be difficult. So I say, if we step back and work and look at more low-level things that sound scary, if we create well-designed tools around communication, data, and manipulation of data, then it's actually easier for a newcomer to come in, learn that library, okay, and then say, oh, well, I know how to do data, I know how to communicate data, and I know how to manipulate that data. I just take those things, combine them together, and I can get any result that I want. So my argument here is frameworks and the easy approach oftentimes are harder because they don't actually give you what you want, because they abstract what people think that you want. But when it comes to programming, you never know what you want, because that's up to the application developer. So
do you think then that there could be a risk that people might come along and naively assume that some of these things are already catered for in GunDB and just use it, and then they've kind of got a big bit missing, like authentication or security or whatever, and they kind of just assumed that everything's kind of taken care of there? Or is that just a case of a documentation and a training kind of thing?
Absolutely. So we're still building out a lot of the tools. So yes, some people have come in and said, well, how do I do auth? And we're like, oh, we haven't built any tooling for that. Do you want to contribute and help? So yes, there is a danger in currently, if that tooling and those modules and that user land activity hasn't already been built out. But I see that just as a problem of time. Somebody at some point will create a passport integration or something like that, and it'll all work out. But the important part of what you said is, yes, education. And that's, again, why I'm going to mention Kyle Kingsbury here, is a lot of people are going into the black box systems that do all and solve all, and finding out that actually, no, when they're in the middle of a crisis with thousands or millions of users scaling up their system, these databases have made claims that they just can't support, and Kyle Kingsbury breaks them down and shows that they can't do what they've claimed. So education is actually really important, and I'm taking the conservative approach and saying, well, Gun only focuses on X, Y, and Z, and it should make it easy to sync some data. And so in that message, yes, you're going to probably have to learn some of the other things. So education is important, because I'm not trying to make too many promises, but my promises, I hope, are specific. And if I can actually kind of pull the discussion back to what Justin was asking about concurrency, and I think he threw out the word transaction, there's this thing called ACID out there. Even though I've jumped into database programming, ACID is a phrase that a database needs to be like ACID compliant or something like that. Even though I've jumped into database programming, I still don't quite know what ACID means, because every single discussion somebody is using one of the letters a little bit differently. I'm actually going to come out and just state that the idea of Gun is to actually allow multiple people to be concurrently editing the same thing. It allows you to do that. But I've noticed that when it comes to transactions or ACID, and Justin, you're probably going to have to correct me here, a lot of the times they want an update, an individual update to a property on a JSON object to be transactional, which means that the entire object is saved exactly at that state. So that means if two people are editing separate properties on a JSON object, you actually want the transactional update or the ACID update, I don't know if I'm using my vocabulary correctly, to blow each other out such that you specifically only get the whole object that you saved at a time. That can be useful for some things, but I have found with most of my web development that that's actually not the behavior I want. If two people are editing the same object concurrently, let's think of a Google Doc, right? I actually want one person to be editing this section of the data and the other person to be editing the other section of the data, and they both merge together and resolve, right? So Gun, in one sense, actually is unwinding perhaps a lot of work out there that says, no, when we're dealing with concurrency, we actually want multiple users to be editing the same thing at the same time and merge those results together, not have this kind of isolated snapshot mentality where it's only one person's entire object that they have saved that somehow is the winner, and we blow out the other edits that happen concurrently. So just wanted to kind of bring that back into the mix.
Well, and the kicker with, when you start to talk about ACID and things like CAP, which is consistency, availability, and tolerance, or partition tolerance, there are inherent trade-offs when you start to talk about how those things work. And from a developer standpoint, if you're implementing anything of that nature, you just sort of have to know where you're headed. And this is a thing with, it doesn't matter what you're doing, whether it's the code you write or the sort of, if it's functional programming or object-oriented or whatever you want to do. Like, you make choices. And with NoSQL, you're looking for scale, right? You want to scale horizontally across the board, and you're not looking for the deep sort of interface that SQL is going to give you, which is mostly associated with sort of ACID, which is going to give you, to the point you're making, basically isolation, right? Two things happen, which one of them happened last, right? You want consistency against it, but NoSQL is going to give you eventual consistency. And from the sound of it, it sounds a lot like you're getting to eventual consistency, right? You have consistent availability, right? I can always write my data. If I'm offline, if the network is down, if there are nodes that have sort of failed on that set, it's not going to matter, right? I can continue to write. The system will deal with it at the end of the day. It's gonna do its side of life and say, hey, I'm back online. Oh no, what happened? That's fine, consistency. And then eventually we get there, like whether that's merging data together or, the vector clock thing, Rike uses that, to some extent. AWS Dynamo, I'm pretty sure, uses vector clocks too. So there is a lot of difference these days amongst a whole bunch of stuff, whether it's the really big stuff, your Cassandras and your of the world and whatnot, to the smaller things that are simply trying to get to that speed point. Because again, it's a series of trade-offs. What do you want to get out of it? Whether that's, if you want to use an ACID model, if you want to use CAP, if you want to use base, if you want to use, there's a whole bunch of different ones. But you as a developer have to make that choice, and that's going to vary. Like, if the API footprint is too big, maybe that's not feasible for your time frame. Because at the end of the day, we do have to ship things. Like, we can be theoretical all we want, and we can understand the low-level functions of systems. But at the end of the day, you have to ship. And that means making choices based on as much information as you had. Is the durability good enough for me? Is the speed good enough? Can I scale it quickly? What happens if it goes offline? So, for the web, that's been hard. Like, that's a hard problem to solve. That's why we have service workers and, web workers and background sync now. And, we get all these new fancy APIs that help us build more durable sort of web applications. And it sounds like Gun fits into that puzzle as a sort of one thing that it does well sort of thing. That's what I'm getting out of this conversation so far. And you can build on top of it, which is great, because building on top of things is generally what our jobs entail. So, if you want to reinvent the wheel every day at work, more power to you, but I'm not going to do that.
These are wise words. People, listen to this man. These are wise words. During the pre-show, I think he called himself a dinosaur, and I think actually dinosaur in this case is really important because he's been around the block. He has history. He understands the problems, and you should really take what he's saying at its face value and then use it to investigate the underlying value. So
keyword investigate. You should always investigate,
yes.
Which is why we do the show.
Yes.
To investigate new things and learn.
I'm going to pick some of these things apart, though. So first off, yes, do not use Gun if you are creating a banking app and you're trying to make sure that every single account across all your users have the correct balance at the exact same time. That is what, as Justin was mentioning, is the CAP theorem, specifically the C of strong consistency. If you're building a banking app, you're going to want to use something that has strong consistency, and that typically means using something that has a master-slave architecture, which typically also means having to run your data through a single box at the end of the day and scaling up vertically. And that ultimately does become a bottleneck. It is hard to scale that up. But if that is your application need, you need to do that and not use Gun. However, I'm going to start making lots of fun disclaimers here. First off, the discussion between strong consistency and partition tolerance and network availability, data availability and network partition. Network partition is kind of what we started with offline first when the internet goes off. Is not a discussion between SQL databases and NoSQL databases. You can kind of maybe categorize them generally in that case, but it is more of the, because you can have SQL databases that are not strongly consistent, and you can have NoSQL databases that are strongly consistent. So first off, I'm going to kind of rewind and talk about this idea of being decentralized or peer-to-peer or master-master. It turns out, algorithmically, mathematically, you can build federated systems on top of peer-to-peer systems. So an example of a peer-to-peer system would be like BitTorrent, okay? You can actually build things like email on top of that. Email is federated. You have these strongman providers like Yahoo, well, goodbye Yahoo, Gmail, and Hotmail, and you have these big providers that communicate with each other, and then you have all of the customers, the users, the clients to the strongmen, the federated systems. So you can create federated systems out of peer-to-peer systems. But you can actually take this another step further, and this is pretty exciting. You can create strongly consistent or master-slave or centralized systems out of federated systems. You're typically then running an algorithm like Paxos across all your federated machines to get one convergent result that is strongly consistent. So you can build strongly consistent systems out of, let's say you can build a Facebook. No, you can build a banking app out of a email app, out of a BitTorrent app. Now, as you're doing that, you're trading off each step you go up the route, right? So you're trading off availability. If one of there we go, that's a perfect example. If Yahoo goes away, and Yahoo is one of the 3 machines that need to make sure that the data has been saved. If Yahoo goes away, we're not able to have strong consistency until we determine that that machine is truly dead, and we can say, okay, now it's only Hotmail and Gmail that we need to make sure that the data has been saved to before we continue. So, but if Yahoo is just temporarily kind of going through some problems, going to come back online, then you have to wait until Yahoo figures out all of its problems, such that then both Hotmail, Gmail, and Yahoo can collaborate together and say, okay, no, for sure, every federated system or every Paxos machine has decided. It's not how Paxos works, but they all have consensus. So if you're running banking, that's important to do that. But now but things are going to be slower because you have to wait until each machine says, yes, I agree with the rest of the system. But I'm going to rewind this down to the BitTorrent level, the peer-to-peer level. I find this level more interesting because that's actually the physics of how things work. If you look out in the universe, there isn't such a thing as a strongly consistent system or a centralized system. Like everything in, whether it's biology or ecology or physics, is distributed. Light itself is talking about distributed systems because it takes time for light or information to be transmitted to another part of the world. So Alpha Centauri versus, just to put it in human terms, it can take hundreds of millions of light years for light from Alpha Centauri to get to Earth. That is eventually consistent. When we see that that star, that supernova, we're not seeing that happening now, or aka in a strongly consistent manner. We're seeing that hundreds of millions of light years ago. It is eventually consistent. So my fundamental argument winds up being that the universe itself is peer-to-peer. It is decentralized. It is eventually consistent. It's strongly eventually consistent, which is distinct from it being strongly consistent. So it makes sense that we can build centralized systems out of these lower levels, but when you start with something that is strongly consistent, you cannot go back down the chain. So again, this is coming back to this discussion. It's intentional on our part to make a system that is emergent. I don't encourage anybody to ever actually build a strongly consistent system on top of Gun, but algorithmically, academically, intellectually, mathematically, theoretically, it's possible. But again, I'm going to now rewind to what Justin said. There's lots of theory out there. You need to choose the tool which is practically applicable to your job and run with those tools. Because yes, it takes a while for theory to be implemented in practice.
No, I mean, but at the end of the day, you have to have things that sort of implement theories. Otherwise, you don't grow, right? And with Gun, you do get a very simple sort of API footprint. You get a very sort of you get a different approach to a problem that a lot of people are trying to solve. Because I think, a lot of people talk about the big ones, your Mongos and your Firebases of the world. But if you look, there's lots of people actually working on this problem, because it is a very hard problem that's not necessarily easy to solve for everyone, because there are always trade-offs, and everyone has a different set of trade-offs that they're going to make as they build platforms and software and the things that sort of run our world around us. So that's, I find it intriguing, because number one, it's not a very easy thing to build. I mean, I would not wake up one morning and go, you know what? Databases, that's what we're building today.
Well, Justin, I'm actually going to be the panelist here and switch it around. Have you ever had production-level nightmares with your database that you did wake up one morning and you're like, oh my goodness, screw on?
I don't know anyone who's worked in systems long enough that doesn't go, you know what? Database is not acting, database is having a bad day. If that takes out half the United States, well, someone should probably come in. Whoever's got the beeper, I don't know. Not me. But
Give us your story. Give us your story.
I mean, I think this. I mean, it's an old story. I mean, the story is that anytime you have any sort of system that relies on sort of big backends, and I've built big backends that are built on really, really big things. And I'm not going to mention any names because that would be bad. But regardless, those things have a tendency sometimes to fail, even when they have failover, even when they're high availability. And a lot of times you inherit. Like, you inherit the systems that came before you as a structure of stuff. And the problem is that you can't readily do that. So, I mean, I remember, probably 10 years ago, a very, very big system on a very, very expensive set of hardware from two very big vendors, just got angry one day. And it turned out to be a very obscure bug in a very low-level system library that you couldn't have worked around. No one could have found it, but it took out a significant portion of operations for, this giant firm. And, there are those problems where you're not going to, the scale has gotten so high that you start to find problems within the system that even the engineers who've worked on the low haven't found yet. And when you hit that mark, you should, to some extent, I was like, wow, we really grew that system out. Who would have thought?
Oh, it's gone. It's just all gone.
But again, this goes back to the redundancy question of the day. Like, you can have failover and you can have things, but you also should have backups. Which I don't understand why people don't back stuff up. Like, at the end of the day, like, it did fail over. It did. Like, the consistency was fine. We didn't lose data. Like, you can plan systems that do this. There are people whose that's their particular job, and that's not necessarily my particular job. But I've helped build those systems. And database failures happen. You have to plan for you have to plan for that contingency. Like, what is your plan to get back? Whether that's multi-data centers or having finding that consistency amongst chaos, because there's a lot of chaos when it comes to databases. Because again, you inherit stuff that you didn't write. There is no design documentation. Like, there are a lot of problems that can lead to failures on many sort of levels when it comes to software. Good teams sort of mitigate that, but that can be itself hard. Like, you have a lot of moving pieces for lots of big software. For smaller projects, it can still be troublesome, particularly when you hit that spiked scale where all of a sudden you're like, oh my gosh, why didn't anything auto-scale? Or why did why are the offline operations queuing multiple requests? Because that'll start to, all of a sudden you start to see the graphs go in a direction you don't want them to go. This is a bad thing. So, yeah, I mean, any system can fail given any sort of, given its own unique sort of circumstances, whether that's at an industrial plant or the thing that runs your website. You can sit there and point fingers to, you can say, oh, it was the software's fault. But at the end of the day, it is our job to write software. So you just sort of have to say, what could I have done better this last go around? Where was my implementation flaw? And ideally, you don't take somebody out for a week and you don't lose a lot of data.
Right. I'm going to jump in because you had actually a little nugget in there I want to expand on. The idea that when you're offline, that the same request might queue multiple times. So if you've looked at Redis and Kyle Kingsbury, they talk about this, and the names are at least once, at most once, and exactly once mechanics. So to achieve exactly once mechanics is actually really, really difficult because our previous discussions of how networks fail all the time. So if you have a mechanic that can handle at least once, that means the same message might get sent multiple times, and you deduplicate that message. You actually have a really resilient system because your server can say, oh, I've already seen that message before, I've already processed it, so I don't actually need to run it through the whole system again. I can just dedupe it immediately. But if any one message as it's trying to get sent happens to fail because of the network that it queues up on the client machine to rerun, you're able to survive that network outage because at some point the message will get sent again and you can process it. So that's actually a really neat nugget that people should go investigate. Look at least once, exactly once, at most once. And I'm biased. I'm on the side of at least once mechanic delivery because to me it gives you stronger resilience, and you can then always deduplicate intelligently, and that's to one degree called idempotency, in order to get more of a stronger behavior on top.
Yeah, and I think the key is to understand how those things work. Because at the end of the day, if a lot of people say, I'm using this, and I go, great, why are you using that? Like, what particular problem does it solve? Because I'm always curious. Everybody has a different approach. Like I could give you my approach for things. It doesn't mean that I'm right. It just means that's the way I know to build that particular type of thing that you want built. There's lots of ways to build software. There's lots of research that's available. There's some great research papers if you're really into reading, sort of the research that comes out of both academia. Microsoft's got a great research department, so does Google, HP. Like, they have great research papers that come out. And you can sort of get you can get a deeper understanding. But at the end of the day, you should know how the thing you're using works. And the reason that it works is if you don't, when it breaks, you have no means to understand, wait, what methodology was it using? Why isn't this right? Or why did I get, what? I needed to dupe this? Those lead to bad days and generally unhappy people somewhere. So, you should always keep that in mind.
Absolutely. I'm actually going to pull us straight back to what Danny was saying about like Angular and frameworks and stuff. The exact same discussion that we're having about back-end systems and what sounds like all this complicated academic stuff is actually realistically the same discussion about if you just take Angular and you start using it, when something goes wrong in Angular, that's your bad day. You're spending the rest of it trying to Google what is this obscure error that is like not even a JavaScript error. So that's why I emphasize people thinking about, yes, what are they building? What are the more low-level concepts? I don't necessarily mean at a like super technical level, but just understanding, okay, I want to take the user's profile and I want them to be able to update their name. And we want that piece to then get replicated across all the users who are looking at that user's profile, so that way they see that update immediately. And we also want to persist that to the server. That doesn't have to be a PhD. That doesn't have to be a thesis. But if you start using tools that you fundamentally don't understand, when things go wrong, you don't know what's happening, and it's going to be a really, really bad day, whether that be the back end or the front end.
Yeah, I mean, and that's just in general. Like again, we're talking about like frameworks versus libraries and all that kind of stuff. At the end of the day, everything that is a tool. I said we're talking about Angular for front end for stuff. Like it said, you start messing around with Angular 2, and this is actually something I think they've done a very good job on, and a lot of the people in the community on like really explaining like the how things are working, like under the hood. Or yeah, you can get yourself into a lot of trouble and you just get some random error and you're like, I've no idea what this means. I have nowhere to start. You don't even recognize where an error is coming from. So and I think we've said that several times already. Is just making sure that making sure that you know about the thing that you're doing. And Node is actually people that do a lot of stuff in Node actually having a kind of the same problem in a similar way with just mountains of dependencies of stuff. We mentioned LeftPad, the LeftPad controversy, LeftPad gate, or whatever you want to call it earlier. But just having just some idea of what you're running and understanding what it's doing. Like you said, you don't have to know the exact underpinnings. I don't need to know exactly how Angular's change detection algorithm works, but I should have a rough idea of what it's doing so that if I start having problems, I can try to work my way through it. And with that, I feel like we could this episode could probably go on for another hour and a half, or whatever. But I think I'm gonna have to cut us off right about now. Mark, we're just gonna have to have you back. We're just gonna have to have you back to talk about more stuff.
Thanks for chatting. Thanks for having me on the show. I really appreciate it. It's been wonderful to bounce ideas back and forth and get a vibe of kind of like how people feel, and really our job as programmers of sitting down and reasoning through these systems. And it's been great chatting. So thank you.
Yeah, no problem at all. If somebody wants to, if they want to get in touch with you, if they have questions, if they want to contribute to GunDB is an open source project. If they want to contribute to GunDB, how do they get in touch with you? How do they contribute to Gun?
Yeah, so the community is really open and friendly. If you go to our homepage or the GitHub repo, you'll see that there's Gitter links. People are chatting on that. So definitely jump on the Gitter. I'll be there. If you want to contact me directly, it's my email, mark@gundb.io. Contributions are always really, really needed, as we've kind of discussed that there's lots of pieces that still need to be built, like authentication, authorization, and those pieces are going to benefit the community overall. But also at this point, we're just trying to get the word out more and get more feedback, have people tell us what sucks about Gun, what bugs and problems are in there, because we're going to be pushing out a production-ready release pretty soon here, and we want to make sure all the pieces are in place for Gun core. So just even starring us on GitHub and tweeting about us, and I don't mean that just purely in a help us market Gun, but just having more of that community there to exchange ideas and banter about these things and have open discussion about databases and what can go wrong. So npm install Gun, star us, tweet us. I'm pretty terrible at Twitter, but I'll try to respond. Get on Gitter, chat with us, ask hard questions, explore interesting things, and together as a community, we can hopefully collaborate and find wonderful answers. And that is the whole point of software and podcasts like this, is to have an open dialogue and not shut things down. Be friendly and accepting and encourage an edifying community. So, thanks.
No problem, and I think that is about as good a place to end it as any. My last note is that for somebody that said they don't like databases, you sure seem to know an awful lot about them. And this has been episode 102 of the Web Platform Podcast, Offline with GunDB. I'm Danny Blue, and we will talk to everybody next week.